On pages 25 and 26 of our Unit 4 notes, we are learning to graph absolute value functions. The first step of graphing an absolute value function is always to identify and then plot the vertex. The vertex being the turning point or the point of the V-shaped graph. My vertex is found looking at the equation itself. The x-coordinate of the vertex is found inside the absolute value and is in fact the opposite of this number inside the absolute value. So in this case, -4. The h of my vertex, hk, is the opposite of this number as indicated by my general form subtracting h. So because we have +4, that means I had minus -4, so h is -4. The k value, or the y-coordinate of my vertex, is just equal to this number outside of, to the right of the absolute value. So the x-coordinate of my vertex is the opposite of this number, -4. The y-coordinate of my vertex is this number outside the absolute value. So I'm going to go ahead and graph that vertex. -1, -2, -3, -4, with y being -2. The next step is to graph the right branch. I'm going to graph the right branch by plotting points using this number a, the number outside and to the left of the absolute value sign. So my slope is 3/1. When I have a whole number, my rise is 3, my run is 1. So up 1, 2, 3/1, up 1, 2, 3/1, 1, 2, 3/1. So there is the right branch of my absolute value function. You would be using a straight edge, but that is hard to do on the computer screen. To graph the left branch, you can either use the opposite of your slope, so either the opposite of 3 being -3, going up 3, left 1, up 3, left 1, up 3, left 1, or you can plot the line of symmetry and use the line of symmetry to reflect the points on the right branch. The line of symmetry is the vertical line, meaning it has an equation of the form x equals, that goes through the vertex, dividing the V-shape into two symmetric halves. The line is given by x equal to the x-coordinate of the vertex. So in this case, x equals -4. You could also just look at the equation and it is again the opposite of this number. So that alternative way to graph the left branch is to use the idea of symmetry to reflect the points of the right branch. So instead of 1 point to the right, I go 1 point to the left. 2 points to the right, 2 to the left. 3 to the right, 3 to the left, 4 to the right, 4 to the left. Then connect this branch with a straight edge and arrows. So we should check our graph. We should check to make sure that, in fact, I have an upward facing V because the A value, this coefficient, is positive. I have a pretty steep line because my slope is 3, not 1/3, which would be flatter. And then I should check my transformation, my predicted transformation. Thinking about our transformations, my V shape should have moved left 4 down 2 compared to the parent function, and in fact it did, left 4 down 2. And also, I want to check to make sure I do in fact have a V shape because every absolute value function, every absolute value graph will be V-shaped. So for each of these graphs, you're going to perform these steps, identifying the vertex, opposite of the number inside, for the x, this number for the y. When there is not a number inside the absolute value, that means it's a 0, 7, 5, and -4. So we plot the vertex. We can find the line of symmetry just by writing a line x equals that goes through that x-coordinate of the vertex. And then after we've plotted the vertex, we will use our slope. If there's not a number in front of the absolute value, I would go up 1/1 with a slope of 1. down 4 over 1, slope of -4, up 2 over 1 for a slope of 2. Once we have the function graphed, we can identify the domain and range. Looking at this one, for example, the domain, all real numbers because we go forever to the left to -infinity, forever to the right to +infinity. And in fact, the domain of all absolute value functions is all real numbers. We are going to look at the y-coordinate of our vertex to determine the domain, or to determine the range. So in this case, the range would be y is greater than or equal to -2.